And that brings us back to that limited dome height test in a picture that we looked at in the mechanical properties class. We said that that error right there, that thinning portion of the metal, was often called an engineering strain, but we're calling it localized necking. And in fact, in that area, that is what you would see in a tensile test when that tensile specimen, as I very carefully redraw the tensile specimen, and let me tell you, that thinning area that you see in the tensile test specimen in a 2D test where you're pulling on something in just one direction, when you see that necking area, that is really corresponding in 3 dimensions to these kind of localized necks. But we want to get away from using that term strain to mean localized necking, and that's when we said, well, engineering strains are really everything that's happening on this entire little test sample. So let's kind of talk about what those strains mean and why they're important. And I kind of like this little cartoon here. When we see somebody looking at a sheet metal panel and they're saying, well, that panel looks good, and you might hear somebody say something like, yeah, that panel looks good. It'll hold water. It's fine. Well, in a way, it's sort of like going in to see the doctor and the doctor looking at you and saying, well, he's breathing, color looks okay, I don't see any blood coming out, so, hey, he's okay. And you'd be sitting there kind of wondering, well, you know, there's some other things here like blood pressure and my temperature and, you know, some other tests. How does this guy know that I'm okay just by looking without any measurement of what's going on? It is difficult to tell that you have a healthy piece of sheet metal. And that's what we're going to talk about here is how do you measure if the sheet metal comes in and you put some circles on it, and when the sheet metal is done being stamped, those circles have turned into ellipses, what does it tell you? And so we're going to introduce two 3-letter acronyms to you right now, the FLD and the CGA. And some of you are familiar with these, no doubt, but let's kind of just spell out what it is we're talking about. The forming limit diagram is a means of displaying a key output, and that key output is strains. Engineering strains are going to be displayed on the forming limit diagram. When we talk about circle grid analysis, what we're talking about is actually measuring the strains so that we can plot those strains on a forming limit diagram. So a lot of times people kind of use these terms interchangeably. Circle grid analysis is the act of putting on the circles and measuring them and plotting them on a forming limit diagram. So it's the two kind of go together, but just so you kind of know what we're talking about here. Now, when you measure strains, you do get a lot of good information. You get location of the strains, magnitude of the strains. You can, to some extent, decipher the direction of metal displacement by reading these circles, and you certainly can find the strain distribution and the deformation mode, and that was those 3 modes that we mentioned before, the stretch, draw, and plane strain. So let's kind of just jump in and start figuring out why we would want to use circle